Recording in progress.
Okay. So you have to write an equation in terms of sine and cosine for this graph here. I'm going to add some conditions as well. Okay. So I'm going to add those conditions. I want A to be positive, H, bless you, and H to be positive. Now, what's the general form for a sine or cosine graph? Y equals what? A times sine, bracket, B, X minus H plus K. Now, why am I being so much stringent with H and A? Kieran, do you have an idea?
Yeah, because you can shift
Totally.
to a cosine value.
Yeah, 100%. And also the fact that you can have the graph open down and then go up again, right? So you can really start really anywhere. So I want to be somewhat also for my own sanity, if I grade this stuff, I want to make sure I don't see a gazillion answers. I mean, yes, there are still infinite possibilities. So let's start with sine. So sine could start here, right? And sine could do this. You'd agree that's one cycle of sine. However, is my H going to be greater than 0? I want to force a horizontal shift, right? So I could do it here and write that as a sine function where A would be negative, but do I want A to be negative? I want A to be positive, right? So where should I start it? Probably right there, exactly right. So it should look like that. So that way I'm forcing A to be positive and forcing H to be positive. Now, if I said A has to be negative and H is positive, then I can start here and go down then up. So you have to be mindful about that. So I'm forcing you guys to think a little more critically about it. So I'm going to start here. So what's my H value then? I'm starting there. How far did I shift to the right? 4. Good. What's my A value? What's my amplitude? 2. Yep, from the midline. Where's my midline? Okay, is what? Okay, we're 3/4 of the way there. You guys are doing great. Awesome. Okay, period. You can really just look at any cycle. It doesn't matter where you're starting or ending. I mean, where you're specifically starting. Just look at any cycle, the length of one cycle. So that's one cycle, right? How long is that? But what's B can equal? B is not 4. Pi over 2. Because if you do 2 pi over B equals 4/1 and cross multiply it and solve for B, you do get pi over 2. Excellent. Good. You got it all done, right? Just write it out, right? That's all you gotta do. So I didn't leave myself enough space. I'll do it up here. Y equals 2 times sine brackets pi over 2 x minus 4 bracket minus 3. I'm not going to give you that general formula. You need to know that. So, you guys got to know that formula. Just, when we do get to trig identities in the next unit, some identities I'll give you, some I won't. There's some that are just so crazy, I have to kind of give them to you. But you need to know this. Let me do that too. Okay. Now, how do I write a cosine? Same conditions. I want A to be positive, H to be positive. But the thing about it, there's only really one thing that's going to change, just the H, right? A is going to be, the amplitude is still the same. The vertical shift is still the same. The period is still the same. Just starting a little differently, that's all. So where am I going to start this guy? I'm going to start up here, right? Exactly. So I'll just say Y equals 2 times cosine pi over 2, but X minus 1. Minus 3. And you can always plug in 1 just to see what happens. Plug in 1, you get 0. Cosine of 0, we know is 1. 2 minus 3 is -1. Makes sense. So not that hard, right? Okay, so that's how you write them. We'll do something similar for cosecant, secant, tangent, cotangent graphs, like writing the equations from. Not today, but maybe tomorrow I might print a worksheet and have you guys practice that, because it's good stuff to do. Okay, why don't you try part B on your own? I'll freeze the screen. I'll do it as well. We'll see. So, oh, my conditions, by the way. David, go ahead. You need what? Sorry.
I can ask in a second.
Oh, okay. My conditions for here. Let's have A be negative, but H still be positive. Oh, yeah, I know. There we go. That's my condition. A's got to be negative to do sine and cosine. David, good.
Yeah, I don't understand how A could ever, you could ever get different A's versus.
You're starting differently. A and H go hand in hand. If they count, they complement each other.
How? So I thought that it's just literally on the, like the graph of the A is.
Yeah, but what if you want to go down, step up? Exactly right, 100%.
But that doesn't change your amplitude.
No, the amplitude is still the same because the amplitude is positive is the absolute value of A. Just the A value changes. You're showing a reflection. That's all. It's just a transformation.
Oh, it's so A could only either be 2 or -2.
Right.
Oh.
Right.
Okay.
It's just a transformation. That's all.
Okay.
So make sure you find your midline first, guys. That's important. Yes, Sam, go ahead.
Both sign and cosine.
Yes, both. Yeah, please.
Your writings.
Yeah.
Okay, at the very least, I have this. Kyle, go ahead. Yeah, of course, yeah. So at the very least, I have this. My amplitude is 25. I'm going down, so I'm going to do negative 25. The length of one cycle is 12. 2 pi over b equals 12, so b has to be pi over 6. We're okay with that. K is 30. Because the low point's at 5, the high point's at 55. Halfway between is 30. Now, let's talk about if I do sine, I want it to be negative. I want to go down first and up. So it looks like that's at we'll see, that's at 6. That's at 0. What's halfway between 0 and 6? So it's gotta be a 3. I know it's not terribly obvious based on the grid lines, but it's gonna be at 3. If I were to plug in 3, well, actually, let's say if I plug in 6. If I plug in 6, I'd have sine of pi over 2, which is 1. Negative 25 plus 30 is 5. So that makes sense. For the second one, if I do a cosine, cosine is going to obviously start at 6 and go up. So that's pretty obvious too. If I were to plug that in, I would get cosine of 0, which is 1. Negative 25 plus 30 is still 5. So you good with that? All's good. Okay, great. Perfect. Good. Let's keep moving. Okay, let's talk about tangent and cotangent graphs. And let's do some transformations of it. And at that point, I think we're good. Because I don't want to start part 5. I think starting part 5 tomorrow makes more sense. Kind of start fresh. I might do part 5 and 6. No, because I do part 5 Tuesday, part 6 Thursday. Well, I was hoping to do 2 days of review with you guys too. Well, let's see. So I could probably sneak in parts 5 and 6 both tomorrow. But all right, so guys, let's go to page 19, and let's just go through the motions here. So this is actually kind of good practice for the homework quiz, right? On unit circle. So sine of 0 is 0, and that's 1. That's 1, and that's 0. That's 0 and that's -1. And that's 0 and 1, right? That's easy. And -1 and 0. And pi over 4, those are both √2/2, right? But I'm just going to write 1 over √2. Just because I feel like doing that. It's the same thing. That's 1 over √2, but then -1 over √2. And then that's both negative, right? And then that's negative, but the other's positive. Again, same thing, √2/2. It's all the same, right? Now tangent is sine over cosine. We know this, right? As an identity. So take the second row, divide by a third row, right? What's 0 over 1? But then that's undefined right here. And then that's 0. That's undefined. And that's 0. Did you guys do tangent graphs last year? No? Okay. All right. So it's not that bad. We'll make sense of it. Okay. That's 1, -1, 1, -1. Okay. So far okay with that? All right. Oh geez, I really wasn't really smart about this, but size this up. Let me just look at that. Yikes. Maybe that will work. Okay, these steady hands. Okay, I'm just gonna go with that. We'll make sense of it. Okay. Sorry, that was terrible. Anyway. At 0, you have 0. We know this, right? At pi over 4, you have 1. At pi over 2, you have undefined. How am I gonna show that graphically when something's undefined? What do you guys think? No. Vertical asymptote. We'll explore that in a little more detail in just a moment. Then at 3 pi over 4, wait a sec, now I'm a little confused. Oh yeah, -1, 0, +1, another asymptote. Seven pi 4, -1. And just for good measure, I'm going to actually do another cycle for negative x values. We kind of extend this just a little bit. So here's what we do. So that's how the graph looks. Looks like that. Generally speaking, we think of it like this: y equals a times tangent. Kind of the same thing as before. There's not really an amplitude necessarily, but there's a vertical stretch for sure. And the vertical stretch is really defined from here to here. In the middle of that cycle to that point over here. That point is actually halfway between the middle of the asymptote. There are technically 5 key points. You have your first asymptote. You have your second asymptote. You have a middle. And we have two quarter points. I just made that up. So what do I mean by that? So your 5 key points. So you have the two vertical asymptotes. You have this one, you have this one, you have the middle right here. And then you have core points, which are halfway between the first vertical asymptote and the middle, and another core point, which is halfway between the middle and the second vertical asymptote. So you're always going to have those kind of points. And the length of the period, how long is one cycle here? It's not 2 pi. How long? It's pi. Because it repeats itself every pi units. Tangent repeats itself every pi units. If you look at the unit circle, it should make sense, because if you're going from 0 to pi, you've covered all the possible y over x values, and then it repeats itself when you go to the bottom half of the unit circle. So the period's going to totally be just pi. So the formula for period is pi over b. That's the formula for period. Pi over b. Mm-mm. When we do the shifts, you definitely want to look at the middle. You want to see how that shifts, because that's where 0, 0 is. You're kind of curious how that shifts. Likewise, the vertical shifts. So here's what we'll do. Let's actually do a transform tangent graph, and then we'll do cotangent after that. So I told you we're going to jump around a little bit. Let's look at 21. Example 1. I'm sorry, page 21, example 1. All right. So I'm going to rewrite like this. Y equals 2 times tangent. Bracket, pull the 1/2 out. X minus 2 pi. Plus 2 pi, thanks. Okay. So we're gonna shift the graph two pi left. Because if you think about it, what if I plug in negative 2 pi right now? What do you get on the inside? And what's tangent of 0? Right. Mm-hmm. So that's where we'll be. Now the period. It says pi over b, right? So it's 2 pi. Mm-hmm. So it means there's a distance between the vertical asymptotes is 2 pi. So we have negative 3 pi and negative pi. If I plug in negative pi, I get pi on the inside. Then get pi over 2. What's tangent of pi over 2 is undefined. So it should be. And if you plug in values close to negative pi, like say, I don't know, negative 3.11, whatever, y is going to start shooting up. Like it just, as you get closer to the asymptotes, y goes up towards positive infinity, down towards negative infinity. And then the quarter points. So by the way, was there a vertical shift? No, right? No. If there were, you got to shift it up vertically. The last bit are the quarter points. Now, is there a stretch? By what factor? So you don't have to think about it. You kind of just do it. And there's your graph. That's it. Okay. Since we're asked to do 2 cycles, we'll do one more. Bless you. So go to pi. And the middle is at 0. I didn't do it to scale, so be it. It's fine. Okay, here we go. Not the best drawing, but we got it. Okay. You're asked to state period, which you did. Vertical stretch, which is 2. Vertical shift is 0. Horizontal shift we did. Yeah, we're all good. Okay. So hopefully you're comfortable with tangent. That's how we go about tangent. So just shift it, but you're going to shift the middle of the graph, right? Based upon the parent function, because the middle of the graph is at 0, 0. So that's how you want to do your shifts. You always want to do your shifts from the origin. Like sine graph, you do the same. The cosine obviously start at 0, 1. That's the way you shift it, but or the midline, I guess, shifts up or down if you have a vertical shift for cosine graphs. But okay, questions? All right. Next up, let's do a cotangent. Okay, I'm going to be a little smart about this time. All right. So notice we're putting cosine in the second row and sine the third row, because cotangent is cosine over sine, right? So we're still going to divide the second row by the third row by swapped cosine sine, right? And again, that's 1 and 0, -1 and 0, 1 and 0. And then that's 0 and -1. Nope, 0 and 1. My bad. 0 and -1. That's 0 and 0. Undefined. 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 1 over root 2. 1 over root 2. -1 over root 2. 1 over root 2. Both -1 over root 2 here. And then shoot. Positive 1 over root 2. -1 over root 2. So 1, -1, 1, -1. Okay. Where are my asymptotes? Yeah, let me do a different color so it stands out. Yeah, exactly right. We didn't talk about domain range. Yikes. Maybe I'll do that tomorrow. So 0, pi, 2 pi. And yeah, there's a point at 0, 0. But it's interesting, it does this actually. So it looks reversed. What's the range here, guys? Yeah, so that's easy. That'll never change. As Kieran stated, the domain is all real numbers except n pi. Whereas for the other one was n pi over 2, with n's an odd integer. So I know you guys can do that. I'm not worried about that. But this is all real numbers except n pi, where n is any integer. Yeah. That's bad color. Sorry.
There's not really a formal way of writing, so just write it.
No, exactly. Yeah, exactly. So, all right. Let's do a transform graph. So here's what I do. Period's still the same. Let's switch to red. Period is still the same. Pi over b. So this case is pi over 2. We didn't shift horizontally, did we? H is 0. So when you look at the shifts, you have to look at the vertical asymptote. You have to shift that first, actually, because that's where it's at x equals 0. You don't shift the middle because it's going to be off. That's just going to change by the horizontal stretch or the period change. So all you do is you switch, but we're not moving that anyway. The period is at pi over 2, so that'll be pi over 2. It's not going to look different than the parent function so much visually, but the scale will be different, right? And then what's my a value? And what's my vertical shifts? So I'm gonna start it here. And that's at pi over 4, right? And 3 pi over 4. The core points, don't worry about labeling because it gets really messy, but that'll be pi over 8 and 3 pi over 8. And then 5 pi over 8 and 7 pi over 8. And you stretch it by 3. Oh, it kind of looks funny. So anyway, the roast is more curved, but that's what you got. So that's how you do that. So again, it's pretty simple, pretty similar process and being pretty consistent, right? Just 5 key points. Nowhere to start, end of graph. Look at horizontal shifts, looking at period, up, down, do it. You're good. We're good? Because perfect. That was the lesson for today. So I think I feel good about that. I don't feel like squeezing in inverse functions. Homework, I'm going to adjust. Most likely, I'm going to assign probably 1 or 2 of these problems. 36, probably 38. I'm also going to assign some tangent cotangent graphs. And I think that's it. Yeah, because we can't do 51 later on because we haven't gone there yet. So it'll be just a handful of problems. Nothing too crazy. Let me just look at the answers key, see what I have answers for, and I'll assign those. That's pretty much it. So, all right, let me stop the video.